Question 1. A particle moves so that its s meters from a point O after t seconds, given by the equation s equals 3 sine 5t. So we want to show that it will perform simple harmonic motion. So the displacement s is 3 times the sine of 5t. 3 is the amplitude and 5 is the angular velocity omega. If we differentiate the displacement, it gives velocity. So velocity is the s dt. And if we multiply the 5 with the 3, it gives a 15. If we differentiate sine, it becomes cos. So the s dt is 15 cos 5t. Acceleration is the rate of change of velocity. So if we differentiate velocity, it gives acceleration. So if we differentiate 15 cos of 5t, the 5 multiplies with the 15 to give us 75. And if I differentiate a cos, it becomes a minus sine of 5t. So acceleration then becomes dv dt or d2s dt squared, and this equals minus 75 sine of 5t. Now we're going to factorize out omega squared, so we're going to factorize out minus 25. And if we take out a minus 25, we're left with 3 sine 5t. So this means a equals minus 25 times s, and since the acceleration is minus a constant times the displacement, this means that the particle does execute simple harmonic motion. Next of all, we want to find how long it takes to move from O to a point 1.5 meters from O. So the equation s equals 3 sine 5t. This equation shows the displacement of the particle after any time t. Now when s is 1.5, we're looking to find a value for t. So 1.5 equals 3 sine 5t. If you bring the 3 over and divide, 0.5 equals the sine of 5t. Now if we get the inverse sine of 0.5, this equals 5t. Now this gives us the first time the particle will be 1.5 meters from O. There actually will be an infinite amount of times, but we're just looking for the first time. So inverse sine of 0.5, this is pi over 6. And this equals 5t. And dividing with a 5, this means that the first time would be pi over 30 seconds.